Number 24. Triangles PQR and LMN are graphed in the XY plane. Triangle PQR has vertices P, Q, and R at 4, 5, 4, 7, and 6, 5, respectively. Triangle LMN has vertices L, M, and N at 4, 5, 4, 7 plus K, and 6 plus K, 5, respectively, where K is a positive constant. If the measure of angle Q is t degrees, what is the measure of angle N? Okay, now if I were you, and I'm getting a problem like this on the SAT, there's a couple of ways you can go about attacking it. One is to give yourself a quick little sketch and kind of see where these points are going to be, and then, sketch your triangles out, do it that way. Or you could put these points into your graphing calculator, depending on your graphing calculator, if it'll draw that triangle for you. The first one, this LMN is going to be a little bit harder. Because we have this LMN with this K, this unknown constant, I'm inclined more towards sketching it. But regardless, what I did is I actually I went ahead and drew out just the PQR, and we're going to get this lined up on the grid that's in the background. There we go. Okay, so there I went ahead and drew a pretty accurate PQR with those points at 4, 5, 4, 7, and 6, 5, respectively. Right, so we have a couple of unknowns here, and they're wanting us to know what's the measure of angle N in this other triangle, LMN, of which we do not know the exact dimensions of it. We know point L is here at 4, 5 as well, so it's touching at the very least this other triangle, PQR. And we're told angle Q here is T degrees. And there's this K. And if we look at our answers, the measure of angle N, it's not a number. It's all in terms of T and K. So this is one of those things where it has to always be true. No matter what K is, this is always going to be true as to the measure of angle N. All right, so let's start by looking just at triangle PQR. And I'm going to draw it over here so we can kind of see it a little bit bigger. I'm going to draw it terribly over here. And we have a vertical line, a horizontal line, and they're connected. And we know, because we can look and we can just count, we can count the sides. This side is 2 and this side is 2. Okay, so 2 and 2. And this is a vertical line going up and down because they have the same x coordinate. And this is a horizontal line because they have the same y coordinate. See up here? And I'm almost cutting it off the screen. But those first 2 points have the same x coordinate. And those other 2 points have the same y coordinate. So horizontal line, vertical line. And when we have a horizontal line and a vertical line, they meet in a right angle. Now I'm hoping when you see this right angle and you see that both sides are 2, you immediately think of a 45, 45, 90 right triangle. It is an isosceles right triangle. All isosceles right triangles have base angles, those smaller angles, of 45 degrees. Always, 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 no exceptions. And this is that little pattern you learned. I'm hoping you learned. Please add this to your list if you haven't learned it yet, where it's a square root of 2 for the sides. That is available as a reference on the SAT, but I always advise learning it so you have that in your head and you know to be looking for it. So, okay, so it's a 45, 45, 90 right triangle. So we already know that T is 45 degrees because this is T right here. This is Q, and there's P, there's R. So I already know that T is 45 degrees. Okay, but we're not being asked that. We're being asked, what is angle N? All right, so let's draw on what we think this must be. Now I'm going to pick a number for a number for K, not Q. Q is in there, the K and the Q and the bleh. I'm going to pick a number for K. And I can just pick any number, any positive constant I want, because my answers here all are in terms of K and T. So this must be something that no matter what number I pick for K, it's going to come out as one of these answers every single time for every value of K and what T is. Okay, so LMN, And I'm going to say k is equal to 3. That's my number I'm picking. All right, so L is at 4, 5. And then I'm going to write over here my point L is 4, 5. My point M is 4, 7 plus k. 7 plus 3 is 10. And then my point N is 6 plus k. 6 plus 3 is 9. And then 5. And looky here, we've got the same thing going on that we had with PQR. We have two x's that are the same and two y's are the same. So it looks like this is going to be another triangle with horizontal line and vertical line. Let's plot it on the graph. We have 4, 5 there for L. 4, 10 is going to be up there. There's my M. And then 9, 5 is right there. That's my N. And so try to draw the straight lines. Microsoft doesn't always like me drawing straight lines. It likes to go up. See, you can't draw a straight line. How about that? I'll connect it. So there, Microsoft Whiteboard. Draw a line if I want to draw a line. There we go. Close enough. It's not the best one. It's a little awkward in that corner, isn't it? There we go. Clean it up a little bit. Make it look a little nicer. There we are. Triangle LMN. And yes, it is also, it's sharing this right angle. We have those two sides there. And we have made another isosceles triangle. And no matter what value we put in for k, it's going to be another isosceles right triangle. Because think about what's happening. This M point is 4, and then it's 7 plus k. 7 was the coordinate right here. There's 7. So then k is this extra distance. And if we're on the other side, down on this side over here, what was the original point? The original point here was 6, 5, and then N is 6 plus k. So we've added another, this is k. K was added to the height of this triangle, and k was added to the base. So those sides are still the same length as each other. They're still congruent. So we have another isosceles right triangle. So it also will have 45 degrees on both sides. So I know now that angle N is 45 degrees. It's the same as T. Angle N is 45 degrees. Angle N is T degrees. It's the same, but that's not an option over here, is it? So you go, wait a minute, Alyssa, how am I supposed to do this then? Well, there's two sort of ways you can look at this. I'm going to show you the way that will work for every problem that's similar to this, and then I'll show you the way that works for this problem, an additional way. So the way that works for every problem is if you have a right triangle, and it could be not an isosceles, so let's say it's a right triangle, it's something like this. This angle here being 90 degrees means the sum of the other two angles is also 90, because all three together equal 180. So if I have 180 altogether and I subtract that one right angle, I'm left with 90. These two together must be 90 because they're the two that are left. 90 degrees are left. So that's always true of a right triangle. This right here is a right triangle. It's a right triangle. And so this one being 45, you could say this one is 90 minus 45, or 90 minus that angle. It just so happens that they're both identical. They're both 45. So we could say 90 minus, like this angle down here, if I zoom in so you can really see what I'm talking about. And use a different color. Let's use like bright blue. There we go, baby blue. So like this angle right here, I could describe it as 90 minus t, that t, because these two together would be 90. So if this is t, that must be 90 minus t. That's another way I could call it. So 90 minus t. And the same thing is here. This one's 45. This is 90 minus 45. T is 45, so I could replace this with t, and this could be 90 minus t. And that is what it is. It is 90 minus t, which is C, my answer. And that's the sort of perspective that could get this problem right, no matter what the other answers are. In this particular case, however, C is the only viable answer because T is the one related to degrees. K is a constant that is related to the length of the sides, not the angles. If we're talking about proportions or how the sides relate to each other, then we'd be talking about K. But we're not. We're talking about the angles. K is not related to the angles at all. And A, B, and D all involve K. So just that right there, you go, wait a minute. K is about the length of the sides. That's not changing these angles. No matter what K is, these angles stay the same. If K had my triangle, if I picked a really big K and it was like all the way up here and all the way out there and all the way out there, these angles are still 45 and 45 degrees. K got way bigger, but those angles did not change. So K getting bigger or smaller would change the other values. It would change A, B, and D. So that's impossible because the angle doesn't change. It's always going to be 45. And as K got bigger, that number, plugging that in, would change. So just the fact that K is in answers A, B, and D means they are ineligible for this, and it must be C. But like I said, the way I was telling you about how the opposite of the remaining angles in a right triangle add up to 90, that will get it right on every question, not just this one where they gave you 3 answers that are impossible. All right, and that's 24. My answer is C. Hey guys, it's Alyssa, and if you're looking for more SAT or PSAT help, go to mathwithalyssa.com. You can get over 25 hours. Yes, 25 hours of test prep, including math and reading and writing. And there's dozens of practice questions, downloadable study guides, you name it. Links to everything in the description down below. Leave me a comment if you have any questions about this video or any suggestions for future videos. And if this video was helpful or useful in any way, please let YouTube know. Like, share, comment, subscribe, you know the drill. Thank you so much for watching. Hope you have a great day. See you later. Bye.